Hey everybody, today we're going to be talking about the Energy Skate Park. There's no real lesson, no presentation that I'm presenting from today, but I do want you to see how to do this kind of stuff. So for today, 3.2, first thing is if you haven't done this discussion, go ahead and do that discussion, and then we're opening the assignment. This is what the assignment right here looks like. So I'm going to make this a bit bigger so we can see this, okay? So also, if you don't do this, I always change kind of that when I'm working on it. So the first thing is there's gonna be 3 parts, okay? And I recommend kind of opening, actually there's 4 parts, excuse me. You're gonna open this right here, and it's gonna open it in a new window. I'm gonna put it off to the side, and I actually kind of recommend that you do the same, is kind of have 2 windows going, one where you can answer questions and one where you can kind of play around with whatever we're doing. So here we go. So the first one, it says select playground. So I'm going to select playground. And for this first one, we're not even going to use a ramp. Okay. All I want you to do is press bar graph right here, and this will show you the different ones right here. And then the other thing is we need to change friction to none. Okay, make sure you do that for this first one. So all you're going to do right now is you're going to move this skater around, and you are going to figure out how can I raise the total energy, how can I lower the total energy, how can I move the skater without changing the energy. Okay. Cool. This first part is moving around without dropping it. You'll notice as soon as I drop it, things change. Okay. I don't want you to worry about it dropping. I just want you to move it around. So part 1 is just moving it around. Okay. Cool. Now, what you can do is you can close that, and then you can go and open it again. And this time you're going to select intro, or you just press the bottom right here is intro. Okay. Again, click on bar graph. Every single one of these simulations, you really should be pressing bar graph on this so you can be analyzing the energy. Okay, and what you're gonna do is you're gonna lift it and put it here, but not let go. Okay, you're gonna answer some questions, okay, and then, oh, yeah, and then you're gonna let go and see what happens. Okay, and you're going to answer some questions about how the energy changes from kinetic to potential. One thing that you should know is in the slideshow and in previous homework, we use the word gravitational energy. That's the same as potential energy in this case. So right up here, this skater right here has a lot of gravitational potential energy. It's potential energy, it's stored energy, but specifically it's gravitational. Okay, so if you see gravitational and it's something that has the ability to do work, bam, that's that. Okay, so that's 2. And then you're going to kind of summarize those 2, gravitational and kinetic. Remember, gravitational right here refers to the potential energy right there. And you want to see is how can I get gravitational to increase? How can I get it to decrease? And how can I get it to be the same? Then the last one you're going to do is you're going to do one, and you're going to go right here, and you're going to go to you're going to click on friction, and you're going to say lots of friction and bar graph. So right now I'm in part 4. This is the very last part, or not the last part, but right here. And now I'm going to put the skater up here. Notice everything is the exact same. Okay. And what's happening. And I'm going to write down kind of what's happening. And what's happening here is we have lots and lots of friction. So where is there friction? Well, there's kind of a few places there's friction. One, there is friction between the wheels and the ramp. Within the wheels, there's the bearings. If you're a skater, you kind of know what that means. And there's also air resistance and stuff like that. But what's happening is the energy is not lost. The total amount of energy is staying the exact same. Look at this. The total amount of energy right here will not change. And in fact, at any point, if I were to add up all of these energies, it would be equal to that. That's the total amount of energy. It's not changing. But what's happening is it's turning into thermal energy, which is heat. So if you were to touch the wheel, or if you were to touch the ramp, or if you were to touch the bearings, they'd be hot. Okay, if you've ever been on a scooter and you are braking on the scooter, you put your foot down on the back, it gets really hot if you're doing it barefooted. That's the thermal energy. So the thermal energy is being produced here, and that's being then transferred to the air around it, or to the ramp. Okay, so it feels like it's being lost, but it's not really. It's going from potential energy, the gravitational, to kinetic energy, the movement, to thermal, and then it's being transferred to something else, usually the wheels or the ramp or the air. Okay, And then you just need to summarize a little bit. Cool. So I just wanted to walk you through how to use this PhET simulation and how to identify these. The main thing here that I want you to get out of it is that the energy is always conserved. It's never created or destroyed. The only time energy is created is if I go like this. Okay, and technically I'm not creating energy. I'm transferring it from my finger, or you can say that the skater climbed up here. Okay, but it's always just being transformed, and it's transformed into different types. It changes different types. Okay, all right. Smash the subscribe button. I don't know if people say that. Whatever, you can do that. Just click on the links. I don't care. I'm not getting paid for these YouTube videos. It's all good. I'll talk to you later. Peace. Stop the recording. Stop the recording.